So, okay, guys, today we'll do our fifth seminar. We'll start from problem 4. What we have today, we'll speak about general equilibrium, but with production. This problem studies a simple two-goods economy with production. Assume there is only one household with the following preferences. So the utility of our household, depending on the consumption of good 1 and good 2, equals to square root out of C1, C2, standard Cobb-Douglas preferences. The household supplies labor inelastically. That means that the supply of labor equals to 1, inelastic supply. What that means? That means that he will supply 1 unit of labor for each wage. Both goods are produced by a single firm which belongs to the household. The firm uses only one input labor, and the technologies are: to produce first good, the technology is square root out of L1. To produce the second good, the technology is 2 square root out of L2, where L1, L2 is the quantity of labor that is put into production of the first good and the second good. First, define a competitive equilibrium for this economy. What is the competitive equilibrium? You remember that this is the situation where we have equilibrium in each market. Yes, that we have in the economy. How many markets do we have right now? We should count the number of goods that we have. How much? We have good 1, the consumption good 1, the consumption good 2, and labor. We have labor market also. So we have 3 markets. So in each market, we should cross the demand and supply and found equilibrium quantity and equilibrium price in competitive equilibrium. So competitive equilibrium will be the allocation good 1, equilibrium quantity of good 1, equilibrium quantity of good 2, and equilibrium number of workers, labor, and the price vector, price of good 1, price of good 2, price of labor is wage, such that demand in each market should be equal to supply in each market. But from where we will get demand and supply in each market? We have one consumer and one producer. Consumer will maximize his utility subject to his budget constraint, and from here we will get demand for good 1, demand for good 2, and the supply of labor will know. And our firm will maximize its profit, and from here we will have the supply of good 1, the supply of good 2, and the demand for labor. Yes, so we should solve the utility maximization program of our household and profit maximization program of our firm. X will solve the utility maximization program of household and profit maximization program of firm. And from here we will get all demands and supplies, and then we will cross them and make markets clear. Yes, equalize demand and supply for each market. Demand should be equal to supply for each market. Then let's start. Or we do not need to solve it. We need to define a competitive equilibrium. Will we solve it? I don't see. So okay, let's do step by step. We should only define right now, but we do not need to find it right now. Guys, please, is it clear?
Yes.
Okay, thank you. Second, in the second point, we should characterize the production possibility set and the production possibility frontier analytically and plot them on a graph. Production possibility set, production possibility frontier. What means production frontier? What means our production possibilities in our economy? This is the combination of all our resources that we have and the technologies, yes, that we have in our economy. And when we combine the quantity of our resources, resource here is labor, resources and technologies from which we can produce goods, we will get our production possibility frontier. Yes. So this is the set of goods that we can consume, that we can produce efficiently. So let's find. In what axis we will draw the graph? Let's name the axis. The axis of goods that we produce. We produce good 1 and good 2. So here will be Y1, good 1, and good 2. So to put some line here, to draw some line, we should combine technologies and the amount of resources that we have. So for equation of PPF, of production possibility frontier, we should express our technologies in terms of the goods. So let us express from technologies. So workers that we need to produce good 1 will be how much? Y1 square. Yes? And okay, L1 will be Y1 square. L2 will be how much? Y2 divided by 2 and square. So it will be Y2 square divided by 4. So express this. How many workers we need to produce the first good? How many workers we need to produce the second good? And when we sum up these workers on the production of the first good and the second good, we cannot, it will be equal to what? To the number of workers we have. And we have only inelastic supply of labor equals to 1. Feasibility requires. So we do not have more than 1. L1 plus L2 should be less or equal than the supply of labor equals to 1. So this is our resource constraint. Put our technologies into resource constraint and we will get production possibility set. Y1 square plus Y2 square divided by 4 less or equal than 1. And we're ready to write down production possibilities set, all bundles that are available for us for production with such technologies and such amount of resources. So production possibility set will be all bundles that are available for us, y1 square plus y2 square divided by 4 less or equal than 1. But production possibility frontier shows us the most efficient points when we use all our resources and we use the best technologies we have. So production possibility frontier is the set of all our production points such that here is equality, such that we use all our resources. Equals to 1. You see the difference? And let's draw it. What is the graph to this function? You don't know the graph for such function. Okay, let's see. Let's put the maximal points of production. If y2 is equal to 0, y1 maximal is equal to 1. Maximum amount of y we can produce is 1. The maximum amount of y2 equals to what? 2, yes? If there will be no 4, the graph will be the circle, yes? But this is ellipse with center in 0, 0. So this is the production possibility frontier. All points that are on PPF and under is called production possibility set. So, and what shows us production possibility frontier? It shows us how many units of good 1 the firm must sacrifice to produce 1 additional unit of good 2. So if our firm decided to produce 1 more unit of good 2, production possibility frontier will show us how many units of good 1 we should sacrifice. Next, point 3. We should find the Pareto efficient allocation. As you remember from the previous class, Pareto efficient allocation is not about prices. We will not have prices here right now. It is about social planning. Yes, the best allocation for our society. In our society, we have whom? We have our one guy who is at the same time the household with utility function and the firm with the profit function. This guy owns the firm. So what we should maximize? We should maximize our utility function of our guy by choosing C1, C2 greater or equal than 0, such that he can consume no more than he can produce of the first good, and he can consume the second good no more than he can produce. And what is the restriction for production of these two goods? This is exactly our production possibility set. So he should consume only the point that belongs to production possibility set. So y1 square plus y2 square divided by 4 less or equal than 1. So this is production possibility set. This is the centralized solution without any prices, as you remember. Centralized solution. Next. I think it is easy for you to see the solution on the graph. So we have production possibility set, so we can consume no more than production possibility frontier, and we have a utility function, so we will have indifference curves, yes? And we should find the highest indifference curve. This indifference curve will not give us maximal utility, yes, because we can move up. And the last intersection with production possibility set that we can afford will give us the best point, the optimal consumption and production point for our economy, for our guide. In this situation, what is the optimal condition? The optimal condition. The slopes of production possibility set and production possibility frontier and indifference curve, I mean the slopes of the tangent lines to these two curves should be equal. See, this is the optimal condition. How we name the slope of production possibility frontier? You know that the slope of tangent line to indifference curve is MRS, marginal rate of substitution. And here?
It's also MRS?
It's, I think it's marginal rate of transformation, something like that. This means how many units of first good we should sacrifice, yes, to produce one additional unit of the second good. It's marginal rate of transformation. But I'm not sure. I thought you know, but okay. Okay, let's solve. First of all, we should prove that we will work on PPF, not we should work on the on this curve. Yes, so here will be equality, and here also will be equalities such that how much we consume should be equal exactly to how much we produce. Yes, we will not waste that we produce. How to write it, how to prove it. We can say that our utility function is monotonic, yes, so all our constraints should bind. Let's write down it in words. Since utility strictly increases in C1 and C2, the first two constraints must hold as equalities. That means C1 should be equal to Y1 and C2 equal to Y2. Then, given the structure of preferences and the production functions, the production possibility set constraint must bind to. Economy operates on its production possibility frontier. Production possibility frontier. So, what will be our optimal condition? We can rewrite our maximization program easier. Yes, we will maximize now. Instead of C1, we now write Y1. Instead of C2, we write Y2 because they are equal. We explained it. So maximize square root out of Y1, Y2. y1, y2 greater or equal than 0, subject to PPF. Yes, we work on production possibility frontier. Y1 square plus y2 square over 4 equals to 1. So now this maximization program illustrates as the illustration for this maximization program is this graph right now. Because now our utility is in y1, y2 axis. You see? Mm-hmm. Okay. And our optimal condition, you remember, I will Google it. I'm not sure that it is marginal rate of transformation, because marginal rate of transformation is for labor and capital in production. Slope of PPF. Let's see. You don't remember from the lecture how it is called?
I'm looking for it. Marginal rate of transformation, yes.
Okay, marginal rate of transformation. Great. So in optimum, for interior solution, we will have marginal rate of transformation of the first good to the second good should be equal to marginal rate of substitution, first good to the second good. So marginal rate of transformation. This is the first derivative from the first good. You remember 2y1 divided by y2 over 2 should be equal to marginal rate of substitution. First derivative marginal utility from y1 is 1 over 2 square root out of y1 divided by 1 over 2 square root. No. No. This will be square root out of y2 divided by 2 square root out of y1 divided by square root out of y1 over 2 square root out of y2. This. Okay. Then revert. From here we will have 4y1 divided by y2 equals to y2 over y1. From here we will have 4y1 square equals to y2 square. And take squares, optimal condition will be 2y1 should be equal to y2 in optimum. This is the optimal proportion of production and consumption in Pareto efficient allocation. Yes? Then.
Why we cancel square roots?
What?
Why we cancel square roots on the right side?
To find y1 and y2. Here is 4, you see? And when we take square roots, we have 2y1.
No, I mean upper one in MRSY 1, 2. We have square roots everywhere, and why we cancel?
When we revert, yes, here will be this goes to the to up, yes, to the first stage. You see? So here will be 2 y2 and 2 square roots.
Okay.
So
okay. Okay.
So from here, this is the optimal proportion of production. Put this optimal proportion into our PPF equation, and we will find the optimal point, the Pareto efficient allocation. y1 square plus, instead of y2, I write this proportion, 2y1 square divided by 4 is equal to 1. From here, you see y1 square equals to 1/2, so y1 star equals to 1 over square root out of 2. And y2 put into our proportion will be equal to 2 multiplied by 1 over square root out of 2. This is square root out of 2. So this point will be 1 over square root out of 2, square root out of 2. Pareto efficient allocation. This is the answer. Please, questions for this point? Notice one more time that there are no prices. We found our only allocation, no prices, because our social planner decides on how much to produce and consume. More interesting is to find competitive equilibrium in our economy. Point 4 of this task is to find competitive equilibrium. Yes. Compute a competitive equilibrium and present it graphically. Is the resulting allocation Pareto efficient? So now we should find competitive equilibrium. Please check the point 1 where we write down what is the competitive equilibrium and what we should do to find it. So our steps, you see, this competitive equilibrium allocation solves the utility maximization problem of our consumer and the profit maximization problem of our producer. From here, we will get demands and supplies in each market, and then cross demands and supplies, and we will get prices. Okay? So let's do all these steps. First step, let's start from profit maximization program of the firm. What we should maximize? Total revenue minus total costs. Total revenue is price of the first good multiplied by the quantity that is produced, price plus price of the second good multiplied by the quantity of the second good. This is total revenue minus total costs. Total cost here for what we spend money. For what we spend money to produce these goods, please answer.
Minus the WO.
Yes, we pay to workers. Yes, exactly. These are only our expenses. Yes, only our costs. Let's write to workers who works in production of the first good plus workers who work in production of the second good. And this we should maximize by choosing okay, y1, y2. But we have constraint subject to this is total cost, subject to constraint. Yes, we have technologies. Yes, so our technology is y1 equals to square root out of L1, y2 equals to square root out of L2. No, 2 square roots out of L2. This is the maximization program of the firm. It should use these technologies. Put these technologies into maximization program, into the profit, and we will maximize by choosing L1 and L2. Price of the first good multiplied by square root out of L1 plus price of the second good multiplied by 2 square roots out of L2 minus V L1 plus L2 And this we should maximize by choosing how many workers will work on the first production and on the second production, non-negative. This is the profit. So we should, this is the function with two unknowns. So we should take two partial derivatives, first to the condition and equalize them to 0. By L1 will be equal to P1 divided by 2 square root out of L1 minus V equals to 0. First derivative by L2 equals to P2 over square root out of L2 minus V equals to 0. This is, as you remember, this is marginal revenue, MRPL, marginal revenue product of labor. Yes, on the first production. And this marginal product of labor, marginal revenue from product of labor from the second production. So from here we will find right now demands of our firm for labor, for workers in the production of the first good. So this will be the demand depending on prices. How much? P1 over 2 divided by V, and this all in square. And the demand of our firm for the second production, depending on prices, equals to P2 over V square. And also we should find our, this is our firm. Our firm has demand for workers, so in market of labor, she demands demand for labor, and she supplies first good and the second good. So also we should find the supply. How we will find the supply of the first good and the second good? From here. So also we'll have supply of the first good and the second good. What we need to do? How much we want to sell with such number of workers that we want to
P1 over 2W?
Yes, we should put these demands into our technologies, yes?
Mm-hmm.
Into technologies. This will be square root out of LD1, and this will be P1 over 2V. Put the demand for the second, for labor on the second production into technology. 2 square root out of L2D will be equal to P2, 2P2, this over V. Okay, so we finished with our firm. Let's move on and let's find everything about our consumer. Utility maximization program of the consumer. C1, C2, maximize by choosing C1, C2 greater or equal than 0, subject to budget constraint. Yes? Our consumer will spend money for C1 and C2. So it will be P1 C1 plus P2 C2. These are expenses. And they should be less or equal than his income, from where our consumer gets his income.
From labor.
Yes, he solves his labor and have wage multiplied by how much labor? 1 inelastic labor supply, yes, multiplied by 1. Plus, what else? This is the most interesting part in this task.
Endowment.
Huh?
Endowment. But there is no endowment.
He has non-labor income. Who is the owner of the firm?
He is also the owner.
Yes, he is also the owner of the firm. So here plus the profit of this firm. Profit of this firm. Labor and profit of the firm. But as we now consider our guy as a consumer, he cannot control this profit. He takes this profit as given, as constant. Because now we consider him as a consumer, but consumers cannot control firms, yes? So here will be constant for him. It's like about prices. He takes prices as given and profit as given, okay? Because now he is only the consumer for us. Это как, дайте по-русски скажу. Это как такое, вот у нас есть один там Робинзон, у него раздвоение личности, да, он и потребитель, и фирма. Вот, и мы рассматриваем отдельно две эти личности, мы их не смешиваем, когда ищем конкурентное равновесие. Вот сейчас мы его рассматриваем как потребителя, поэтому он прибыль, он не может менять, потому что он сейчас не фирма.
Это получается экономика шизофрениста, да?
Ну почему? Ну, то есть это просто очень упрощенная модель, да, Робинзона Круза. Вот. Потому что и так, да, не очень просто. Представляете, да, если там было еще больше всего там народу, это было бы очень сложно для вас. Окей, continue. First step. Our utility function is monotonically increasing, so our budget constraint binding. Or you can say preferences are monotonic. That's why budget constraint binds. For interior solution, you remember the optimal condition. Marginal rate of substitutions should be equal to the price ratio to the slope of the budget constraint. Interior solution. The slope of the tangent line to our indifference curve should be equal to the price ratio, the slope of the budget constraint. Yes. So marginal rate of substitution, we counted it. It's C2 over C1 should be equal to P1 over P2. So in optimal proportion of consumption, C2 equals to P1 over P2 multiplied by C1. Put this optimal proportion into budget constraint. P1 C1 plus P2 C2, it's P1 C1, one more, equals to V plus profit, optimal profit. Then from here, this is the demand for consumption good, the demand. That depends on prices and wages. Will be equal to V plus profit over 2P1 and demand for the second will be equal to income divided by 2 prices of the second good. And we know this is for the market of the first good, for the market of the second good, and for labor market, we know the supply. The supply for labor equals to 1. So we have everything to cross. So our next step is markets clear. So we should intersect demand and supply in each market. Let's see. Let's start from labor market. So firm needs labor for production of the first good and the second good. L1D plus L2D should be equal to the labor supply. And labor supply is an elastic 1. Put P1 square over 4V square plus P2 square over V square equals to 1. Solve what we should express from here. As we are working with labor market, we should express from here wage. Yes. So wage square will be P1 square over 4 plus P2 square. And wage will be P1 square over 4 plus P2 square and square root out of this. And let's consider market for good 1 and market for good 2. Because you see that we don't know what will be the profit. Yes. So for not considering this profit, we can divide demand of one for one good to demand of the other good. Let's see. Demand good 1 market. This is the demand for good 1, C1D, should be equal to the supply, Y1S. And market for good 2, equal, here, the demand for the second good equals to the supply of the second good. Here, S. You can find from here, you can solve and then express everything. But easier to divide one to another. To divide. Let's see, let's do this trick. Like this. What we will get? P plus P star over 2 P1 divided by V plus P star over 2 P2 equals to Y1S divided by Y2S. P1 over 2V divided by 2P2 over V. Revert everything, and what we will get? P2 over P1 equals to P1 over 4 P2. Yes? Then 4 P2 equals to P1 square, P2 square, 4 P2 square. And That's why P1 equals to 4 P2. This is the optimal price ratio.
P1 equal to 2P2.
Yes, thank you. Because we take the roots. Yes. So P1 over P2 equals to 2. This is optimal. We can put this into wage, and we will find wage. For example, we can write in price ratios, or we can say that one of the prices equals to 1. Like we can write in terms of price vector. You remember, you can normalize one of the prices in the market in general equilibrium. So let's say that we have to write let's say that assume the price of the second good equals to 1, normalize it. Then P1 will be equal to 2, and then wage will be equal to square root out of how much? P1 square 4 over 4, 1 plus 1. This is square root out of 2. So the price vector, optimal price vector, will be price 1 equal to 1, no, equal to 2, price 2 equal to 1, and wage equal to square root out of 2. So we can normalize one of the prices. And then now we have all prices, and put these prices into demands or supplies, and we will find competitive equilibrium allocation. Put, for example, how to find easier. I think easier is to find from the firm. So Y1 star will be equal to, put all these prices into supply function, because into demand we need to count a profit, and it's not, I don't want to do it. So this will be P1 over 2V. 2 over 2 square root out of 2. This is 1 over square root out of 2. And Y2 equals to 2P2 over V. And it is equal to 2 multiplied by 1 over V square root out of 2. And labor, it is because inelastic supply 1. Yes, we'll spend all our resources in the economy. Yes, all workers will work. Okay, so this is competitive equilibrium. One more time. So price vector 2, 1 square root out of 2. Then competitive equilibrium allocation. Y1 equals to 1 over square root out of 2. Y2 equals to square root out of 2. And what else? Wage is equal to, labor is equal to 1. This is competitive equilibrium. We found it. And what you can tell me about Pareto efficiency of this allocation? Is this allocation Pareto efficient?
Of course, yes.
Of course, because it's the same point we get, yes?
Mm-hmm.
Let's write down the The result in allocation coincides with the Pareto efficient one. Yes, what else? Not all labor, but we also should find labor for the first production and for the second production. This one, but this will be 1/2, 1/2. Let's write. Result allocation coincides with the Pareto efficient one. But also, how we can answer this question if we don't, if we did not count the Pareto efficient allocation before, we can say that according to first fundamental welfare theory, competitive equilibrium will be Pareto efficient. Let's write down it also. First fundamental welfare theory will tell us that if preference is locally non-satiated and production technologies also, then, and market's clear, blah, 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 then competitive equilibrium is Pareto efficient. That's all. This is, yes. That's all about the first problem. Let's answer our true-false questions, and that's all. First, all points belonging to the production possibility set are Pareto efficient.
It's false. Because only production possibility frontier is Pareto efficient.
Yes, exactly. This is false. Because only points belonging to PPF are Pareto efficient. But what else we can write? What else we can write? Let's write only points at PPF are Pareto efficient. If point is under PPF, then we use not the best technology, or we use not all resources, or both, so we can make Pareto improvement. If point is under PPF, then we use not the best technology, or not all resources, or both, such that we can make Pareto improvement. Pareto improvement. On the graph, you can show that if this is PPF, here good 1, good 2. If point is under PPF, we can increase the production of the one good without decreasing the production of the second good. Yes, you can move here, or you can move here, or you can move somewhere here. So all these points will give us Pareto improvement. Yes, from this point, all these points will make Pareto improvement. See? Second, the production possibility set depends on both the technology and the resource constraint.
It's true.
Yes, exactly. Depend on technologies and resources constraint. Yes, it's true. And we say, let's see. I will show you examples. We had such PPF, and then we increase the number of resources, only resources, and technology does not change. So it will move like this. Here, here, here. Yes? But if we change here, the increase in resources. But if we change the technology and the amount of resources will stay the same, it will be like change in technology, resources constant. And here was technology constant. Here will be like this. Yes? So technologies gives us the shape of production possibility frontier. And resource constraint will give us the size of production possibility set. Yes? Let's write down it. Technologies define the shape of PPF. And resource constraint affects the size of PPS. Okay? Please ask about this. This is clear.
Everything's clear.
Stop. Okay. Let's stop the recording.